Hello, this is our first piece of our lesson on adding or multiplying and dividing rational expressions. I'm going to do a couple of practice problems from the notes and then a couple of more in-depth practice problems and some that look like the ones you're going to see in the homework. This will be a series of a couple of videos, 2 or 3 or 4. So just to start off, rational expressions, remember, are expressions that look like one polynomial divided by another polynomial, p over q usually. And we can multiply, divide, add, subtract. We'll talk about adding and subtracting later, but right now we'll be multiplying and dividing. So because these things are basically fractions, we're just going to multiply them as though they are fractions, which means you multiply the top and you multiply the bottom. So that's x times x minus 3 over 5 times 7. So it's like x squared minus 3x over 35. That's how you would multiply this and this. Some of you might be like, do I have to multiply this out? Not really. If you wanted to call it, you call it that would work just as well. I'm not really convinced one of these is simpler than the other, so just pick whichever one you feel most comfortable with. So these ones, this problem was the first one in the notes, and it's like kind of easy because there's no common factors among the top and the bottom, but that's not true for the next one, which is 5a cubed over 4 times 2 over 5a. And you can multiply this together first, and you get 2 times this is 10a cubed, and 4 times 5a is 20a. Then you can see that there's some things common at the top and the bottom. For example, the top has a 10 and the bottom has a 20. So that's like, you can cancel a 10 out of the top and it leaves a 1, and a 10 out of the bottom and it leaves a 2. And there's an a on top, a cubed on top and an a on the bottom. So this is like 3 a's and that's like 1a. So that goes away and it leaves 2 a's up here. So this whole thing becomes a squared over 2. And that's a fine way to do this problem. But you could also maybe think about this, and we're going to do this again in one of the other problems, is you could do, you kind of cancel first. I can see that maybe there's a 2 here and a 4 there. This is, I'm going to multiply. I could maybe cancel that out first. It's the same operation I did before. I'm just doing it before I multiply. And then the 5s over 5 is just 1 over 1, so that cancels out. And 1a on the bottom, then 3 a's on top. Leave behind 2 a's on top when I divide them. So I get a squared times 1, which is a squared. 2 times 1 on the bottom, 2. Gives me the same answer. So you can do it either way. Whichever way you find to be the easiest for you. And the dividing works essentially the same way. The difference is that when we divide fractions, we multiply by the reciprocal. So multiplying is pretty much the same as dividing, but I have to flip over the bottom fraction first, or the second fraction. The first problem in your notes looks like this. And this is basically the same as saying x minus 2 over x plus 1 all over x plus 5 over x plus 1. We don't use this division symbol a ton, but we'll use it sometimes here because it's sometimes easier to write them that way. But either way, you flip, whatever you guys say. You flip the second one over, take the reciprocal, flip it over, then multiply as you normally would. So I flip this one over, I multiply. So this one stays the same. I believe this is the keep, and keep, change, flip. I change that sign, then I flip this one over. And this is one, of course, where it's going to be easier to cancel things out first. I don't want to multiply this together, like FOIL that, and then multiply this together, FOIL that, and then factor it again to see that there's common factors. I can see right now that it's x minus 2 times x plus 1 over x plus 1 times x plus 5. Now I can just cross these off right here and get x minus 2. I don't know why I keep writing those parentheses. I don't need them. So dividing is essentially the same as multiplying. And again, like I did over here, oop, I erased it, or I did it earlier where I crossed off everything before I multiplied. I can see that this is going to be, there's a factor of x plus 1 on the top and on the bottom. What I want to do before I multiply, I can just cross those off, and all that's left on top is x minus 2. All left on the bottom is x plus 5. So this is the same as that, and that's not surprising at all. And then the next examples are just ones where you factor first. So I'll do those in another video, and then I'll do the 2 practice problems, and then I'll do some that look like your homework.